Ale, man, how are you doing?
Hey, very good, Charles. How are you doing?
It's been good. Build was great.
Yes, it was a great event.
Cool. Is that why we weren't here? Didn't we? When's the last time we did this, man? Was it June or?
Yeah, a couple months ago.
All right.
Like that.
Right on. So we are sticking to our 1 month thing. That's
yes.
cool.
Nice.
So we're going to try something new today.
All right.
Right? Let's switch.
Okay, let's switch.
Okay, I'm going to be you, and you're going to be me.
Right.
I'm now a real Italian, and you're a fake Italian.
Are you going to Italy on vacation soon?
Yes, but I'm not going to take my wife and kids.
Okay, good for you.
But I guess I would have to if we're trading.
Exactly.
So, who did you interview, man?
So I interviewed James McNellis.
Nice.
Great guys on my libraries team. Very excited to do that. It was fun, actually.
Cool.
And we chat about, Stack Overflow, because it's always there, a lot of answer, replies, and so on. And so I really like the space. We really like it. We talk mostly also with our documentation folks.
Okay.
And then we talked about, what is working right now, on the C runtime, some interesting tidbits. Go watch the interview, then we talk about it at the end.
Excellent, man.
It's interesting.
So this is old school, right? So you just took a camera in there, and
the camera.
In fact, it's really old school.
It's a camera with the tape. Now you have to turn it. They made fun of me.
Well, hey, if you want to do the real switch, man, we get a nice HD camera.
Okay.
And don't worry about mics. Just talk loud. You don't have a problem doing that.
Okay.
All right. So I want to say one more thing. I mean, there are a lot of interesting things that have been going on.
Yep.
As people know, there was a relatively good C++ presence at Build.
Yeah.
Right?
Yeah.
Eric Broomer's talk was killer. Herb's talk was killer. Schreeder's talk was killer. Tarek.
Yeah.
There was GoingNative Live.
Yeah.
So that kind of rocked the house. And Herb's talk.
Yes.
He announced GoingNative 2013.
Super excited about that. Yeah.
Exactly. But I guess because it's live, these guys out there think they don't have to come. And what I have to say about that is you're crazy. Do come. Do be there, because the people that are going to be in the room are going to be amazing.
The networking is great.
The networking is incredible, man.
And plus, you talk with the right people, right?
Yeah.
Google.
You can just have a beer with Bjarne. You can't do that when you're watching something live, streaming in your little video player. So register for GoingNative, man.
See you soon there.
Rock and roll.
Hello, everybody. This is Ale Contenti from GoingNative Channel 9. I'm here with James McNellis from the Visual C++ Libraries team. Welcome to the program.
Thank you.
What's your name? What do you do? Tell us more about yourself.
Yeah, so as you said, I'm James. I'm currently a developer on the Visual C++ Libraries team, on the core libraries side of the team, and we work on the C runtime, the C++ standard library. We also support legacy libraries like ATL and MFC. So I specifically am responsible for the C runtime libraries going forward.
Right now, yes.
Yep.
Cool. Where do you come from?
Yeah, so
always been C runtime?
I have not always been working on the C runtime. So I joined Microsoft about 3 years ago.
Okay.
I started off on the Blend team, which is the XAML designer tools, and I did a lot of work on that team to help integrate the designer into Visual Studio, and then to add support for Windows 8 apps and C++ projects.
Oh.
Then last year, I joined the C++ team, the libraries team, in September, and I started off working on a number of different projects. I first started off just working on like everything. I had a bunch of bug fixing I did in the C++ standard library, and then a bunch of work for C++ CX to fix some bugs there. And then my predecessor, who was maintaining the C runtime, left the team, and it was thrown at me.
Mahmoud,
yes,
he went in our position, yes.
And so it got thrown in my lap, and I have to admit I was a bit disappointed at first, because I'm a big fan of modern C++ and building awesome C++ libraries, and here's this ancient C code base that's older than me in some places, I'm sure, and I now get the opportunity to maintain it. But it turns out it's been a lot of fun.
Great.
It's been a really cool project.
Yeah, we can talk a little bit about that.
Yeah.
It would be great, I noticed that you have a Stack Overflow t-shirt. Well, I don't know what Stack Overflow is.
I do have a Stack Overflow t-shirt. So Stack Overflow is a question and answer website where people ask programming questions and other people answer them. And I've been contributing there for, I think, 4.5 years, 3.5 years, maybe.
Yeah.
I actually started off contributing by asking a question. I was confused about some template thing, and so I asked a question and got an answer in about 20 minutes or less. And so I was like, wow, this is really cool. I should start answering questions too. And so it's
We really like the site.
It is.
It's great.
It's wonderful.
It's amazing. Yeah.
I'm really,
I mean, kudos to everybody that contributing there. Absolutely right. Of course to you, but billions of people out there, right?
Yeah, I mean, it's. I think the coolest thing is that there's people from like practically every perspective. It's not Microsoft C++ centered. There's people that work on G. There's people that work here. There's people that build all kinds of C++
And
software.
it's not only about C++ either.
Well, exactly. Yeah, there's programming of all varieties. Even PHP, if that counts as a program.
Attenzione. You're gonna get some enemies on the program.
Probably.
Cool. Yeah. So that's great.
Yeah.
So you're really pushing it for it.
Absolutely. I mean, I encourage people around here to try and contribute more. I email people questions when I find questions that I know someone here has the answer to, and currently I've been trying to push. We have a lot of internal mailing lists here at Microsoft where people discuss, C++ and other programming languages and things, and most of the discussion, could be public. There's nothing internal or top secret that's going on, but trying to push a lot of those discussions, onto public sites to try and get that information out there, especially for things like Windows Store apps where there's a lot of information that could be really helpful to people.
Absolutely, that's great.
So I've been working with Eric Battaglia, who's our community PM.
Of course, but he owns the VC blog.
He does. Yep.
Nice and please. Yeah, that's great. That's really Thanks for giving us some points. I mean. Pointers to StackOverflow in general, So let's go back. I mean, this is your office, right?
Sure, it is. Yeah,
that's cool. Look at that, books. Oh, you have this nice painting. Look at that, Venice. Very artistic. Did you paint it?
Are you going to show them my friend?
Oh yes. I want to show the bear.
Yeah.
That's so cool. What's the story of the bear?
Yeah, so I think it was 3 or 4 years ago. I don't remember if it was my birthday or Christmas, but my parents asked me what I wanted for a gift, and I told him I didn't want it. I didn't give him any ideas, and so I went over to their house, and he was waiting for me.
Sweet.
So it was. It turned out really well.
Does he have a name?
So yes, his name is Ivan. He was named by a colleague at a former company that I worked at.
Oh, okay. No geeky C++, no like Void Star or stuff like that. Okay. No printf bear. Okay. I think we like to hear more about your experiences. In moving some of the old C code, to C++. What can you share? If you can, right?
Yeah. So one of the things I've kind of been working on, as sort of a long-term project, nothing short-term, has been to try and modernize some of the C runtime sources. We have a lot of cruft in there. There's comments about how things move around in registers in 16-bit Windows, and we don't actually care about that anymore.
Hopefully.
So it's kind of, in a way, it's kind of a software archaeology project where I get to go dig through and find out what's really there, what pieces we need to keep, and try to move all this ancient C code and slowly start using modern C++ features to improve it, like RAII and templates and other things. So there's been a lot of opportunity there. Some of the things that I've been working on, we use a system. We use a system of macros called tcare in our sources, and many of our customers use it, where there's a header tcare.h, and if you define Unicode, then all of these tcare functions and types work with wchars or wide strings, and if you don't define Unicode, then they work with narrow strings or just chars. And so we use this all over in our sources, and we oftentimes we'll have one CPP or we'll have one .c file that works for both, and by default it'll be compiled as for narrow strings, and then we'll include that file in another .c file, and we'll just define Unicode, and then we'll build it a second time. So going through and trying to replace some of that with templates to use a more modern form of generic programming, which not only improves the readability of the source because there's a lot less if-defs, we can go search for things much easier, the IDE likes it a lot better, but it's also a lot easier to maintain because we don't have all these macros everywhere flying around. So yeah, that's been one of the
cool.
big areas.
Yeah.
I think a recent change set that I put in, we actually added R value references to a couple places, and even a variadic template. So it's been interesting to find out what limited ways I can use C++ in this C code base.
Yeah.
Yes. So another area that I've been working on improvements as I've been trying to, in the CRT we have to use structured exception handling in various places. So
Right.
for example, when we take a lock, we need to use a try finally to ensure that we
Of course.
always unlock. And one of the things I wanted to do was replace that with RAII instead of the try finally. But it was pointed out to me that RAII does not have the exact same semantics. So destructors only get called when C++ exceptions cause unwinds through the stack.
Right.
But if an ordinary structured exception, like say an access violation, unwinds through the stack, they won't get called if you use certain compiler options that we use. And in general, you don't want to handle these exceptions, but we do want to provide users with the ability to handle them, and we want to make sure that the CRT is at least in a somewhat sane state when we return control to them. So we want to make sure that we do the unlocks. But one of the problems that we have is that I still want to use RAI elsewhere in the CRT, and you can't have a single function that uses classes that have destructors and try finally. You can't mix the two in a single function. The compiler won't let you. And so one of the tricks that I was actually just working on yesterday was using lambdas and a function template to...
No macros.
No macros, yeah. Using lambdas and a function template to encapsulate all of the structured exception handling machinery so that we can actually mix things much more easily.
Wow.
So I don't know if you want, I can
Yeah, I'd love
show
to
an
see
example
that.
of
Yeah, that would be some template fun. Yeah, absolutely.
So we have these two functions, and they take locks, and they actually have a couple parameters that let us say which lock we want to take, but for the moment this is good enough. And then throughout the CRT, anytime we take a lock,
and this is the old coding. So
this is the old code, yeah. So what we do is we'll take a lock in the code, and then we'll have a try finally block, and we'll actually do our, our actual operations here in the try block. And then in the finally block, we'll do the unlock, and this ensures that if any structured exception unwinds the stack and is actually handled somewhere, we'll unlock the lock, and we'll make sure that we don't cause deadlock somewhere. So the problem is that let's say I want to use a smart pointer in this function. So let's say that up here I have, I want to use what we have a this would not work because unique pointer has a destructor, and you can't mix types that have destructors with the structured exception handling machine.
So the compiler will get mad at you.
The compiler will not compile; it'll be very angry.
That's good.
So what I've done in order to do this is I've basically taken advantage of lambdas. So I've written a function template called lock and call. And what it takes is it takes a callable object. And what we do in here is we basically move all of the try finally code into here. So and in the try block, what we'll do is we'll actually just call this callable object that was passed in. So what we've done here is we've encapsulated all of the structured exception handling machinery into one place. So this function can't use anything that has destructors, but that's okay because it doesn't have anything that has destructors. It's just going to call this other function. And then what we can do is we can replace all of this code with a single call to this lock and call, for example. this would do the exact same thing that this block here did.
Of
and
course.
inside of this function, we can use any RAI types that we want, and outside of it, we can use any RAI types that we want, like this, and we'll capture them. And so we basically forward all these types through, and since they're never in the same function as the try finally machinery, we don't have to, we don't make the compiler angry.
Right. So basically, here you're going to put a unique pointer X just outside the code.
Yep, and then so in here, since we're capturing everything by reference, we could do, X equals
Exactly, you can
set or what have you. And actually, I did miss one thing. This doesn't actually return void. It's because oftentimes a pattern that we have in the CRT is we'll have two functions. So we'll have one function like fread to read from a file stream. And then what it'll actually do is it'll just take the lock, and then it'll return whatever a function called fread no lock returns. And so that function doesn't require the lock to be held.
Right.
And the reason we do this is because internally we call a lot of functions, and we don't want to keep acquiring the lock over and over and over again.
Because we already have the lock.
We already have the lock, and so so it allows us to reuse functionality and avoid all this overhead of to keep acquiring things. So really, we'd like to be able to return whatever f returned, and so. Up here, we'll actually return auto. And
That's hard to write by memory.
it is. I think this is correct. And we want to return the type of the function call expression.
The operator.
So then in the function, we could write a return statement here.
Right.
But there's an additional caveat that returning from a try statement is actually it's not performant. And the reason why is returning from a try effectively does the same thing that an unwind operation does in the stack. So when we write real code in the CRT, what we do is we will have a variable.
Store the
I'm
results.
just going to call it int for the moment. We'll have a variable outside of the try block, and then we will assign to it the result of calling the function, and then at the end we'll return it. And then in here, if you want to break out early, there's a keyword called __ leave that you can use to leave the try block.
Right.
So we use that instead of return. But up here, instead of int, since we're returning this decal type, this would actually just be a decal type.
Right. Exactly the same.
So yeah, this has other benefits as well. Like I was saying, we actually have to pass the name of the lock into these functions. And so in this implementation, which we've been using for a while, many years, you have to name the lock twice. Once here when you lock, and once here when you unlock.
All right.
Potential. We haven't done it yet,
Yes.
but there's potential that to screw that up. And here, we would actually pass the name of the lock into the function.
Right.
You only have to pass it once. It also substantially cuts the number of lines of code that just boilerplate code that we have to write, which is handy.
And it's nice that and now the lock and call, for example, is something you can reason about it a little better.
Right.
Because it's a function. You can. You can imagine you throw more analysis at that, or
Yep.
Or especially around lock inversion and so on. Not that we have anything like that right now.
Absolutely.
But
yeah.
you can imagine a few machinery that you can. Did we do anything related to rings and level of locks and so on?
We do have a lock hierarchy in the CRT of what locks can be acquired before what other locks. But in general, there's very few places where that matters. One place that matters is the I/O library is actually in two parts. So there's the low-level I/O library, which has the _open, the _read.
Of course.
That deals only directly with the files. It doesn't do any buffering. It doesn't do any formatting or.
With the files coming directly from the system, from Windows.
It's basically
really.
just a wrapper over Windows. It's similar to the POSIX APIs.
Windows FDs, yeah.
And then on top of that, we build the std.io library, which has the familiar fopen, fread, feof, things like that. And both of those layers have locks because they can be used independently. They may not, one file may not correspond to one file handle. And so we're always very careful that whenever we need to acquire both locks, we lock std.io before we lock low.io.
Of course.
But in general, most places we don't need to acquire two different locks. The CRT has maybe 24 locks, like global locks that we use, but they're for different types of functionality that you don't usually have to mix and match.
Yes.
Yeah.
Well, 2000 locks. That's a lot. Lock families.
It's so most of them don't actually get used very much. So like we have a heap lock and a debug lock. They're only used in the debug implementation. We have some of those global locks are for opening and closing files. We need to be able to lock the global data structures that we have. There's an exit lock. So most of them are things that they're not frequent operations.
Yeah,
it's not like you're calling sign.
Very localized.
Call sign, we're going to go and lock.
That would be bad. Yes.
Yeah.
And does this perform, of course, very, very similarly to the old code?
This will perform roughly similarly. There may be a slight amount of overhead because of the added use of RAI. So destructors are not. The overhead would be in the single-digit instruction numbers, basically, just to update the SEH stack on x86.
Yeah. Especially on x86.
On x64 and ARM, I would expect this to perform basically the same.
Yeah, exactly.
And
that's great.
To be honest, the kind of things that we're locking, we don't, 1 or 2 instructions are not the kind of things we're worrying about.
Yes, so, that's not the the problem there. Absolutely.
So, but yeah, this is brand new, so I have no idea if it really works.
Right.
I just wrote it yesterday.
That's great. Beautiful. Yes.
Yeah.
So please debug.
Yeah.
Hopefully you can read it, and I'll ask James on Stack Overflow if it doesn't work.
Yes. Or ask me how it works. If you have questions.
Exactly.
Yeah.
Yes. So yeah, that's pretty cool. Yeah, that's great. We love to actually push the code forward and use the new features ourselves.
And I think this is using. So we're using templates, we're using R-value references, we're using decal type.
Auto return.
We're using auto,
as a return type.
We're using RAI and move semantics if we were using unique pointer.
Make unique.
Yep. But at the same time, we're still using the ancient, structured exception handling that sometimes, like in this case, is absolutely required. And so it's
and this is a system. This is system programming, so you have to go down
absolutely
to the to the extension we give you to actually understand specific things inside Windows, right? But it's great also that these isolate, for example, this specific extension to a very, very precise piece of code.
Yep.
So this is really interesting, right? That's great.
And I think that's one of the reasons I really enjoyed working on the CRT. Like when I first started off, I thought I was just going to be fixing a bunch of horrible bugs, and we have had some, bugs that I look at. It's like, oh my gosh, this is awful. I don't want to debug this. But the opportunity to modernize it and to add these new features in and to make use of them where they're appropriate, it's pretty awesome.
Yeah, absolutely. I completely agree. Can you share one of the most funny bug you found or most funny issue? Maybe it's not a bug.
The one that I had the most fun debugging was we had a bug where, right after a process was starting, we were having an access violation in the CRT exception handling machinery. And I started at it for a good 4 or 5 hours before I was finally able to figure out, and it was literally just staring at it. I couldn't even, think of where to look in the stack trace because everything looked fine. And it turned out what was happening is so when you have a DLL, and you write your DLL main, that's not actually the DLL main that the OS calls. There's another DLL main function called CRT startup or something like that, that the CRT registers as this is the DLL main. So the CRT registers it, and then it initializes all your global variables, it does all of the CRT initialization in your DLL, and then it calls you.
Right.
And so we had this, what it turned out this issue was we would do all this initialization, and that includes setting up the heap and setting up the exception handling machinery, and we would call into the user's DLL main. And they would leave via structured exception, which you're absolutely not allowed to do. There's do not ever do that. And so the structured exception would hit the CRT, and we have a finally block to clean up ourselves. Because we, if the user's DLL main fails, then we want to make sure that we do all the correct cleanup on our end as well. So we did that, and what we did is we shut down the exception handling machinery and the heap, and then we returned. Well, it turned out that the user code in this case had also injected their own DLL main that was called before ours, and in there they were doing something that tried to handle the exception. Well, trying to handle that exception called back into the exception handling machinery, which had been shut down, and then we would throw an access violation. which then would roll back out to the user code, and they would catch it again, and it would end up back in CRT. So we ended up basically with a stack overflow caused by infinite access violations.
Perfect.
So it was.
It was perfect.
It was interesting. It was
Nice.
like a perfect storm of things.
Yes.
But
and did you have the sources to debug these, or was just post-mortem?
I'm not going to say which team it was, but I did have the sources in this case.
Because it's very hard to debug with just dumps.
It turned out the reason that they were throwing a structured exception in the first place was they were trying to call a delay-loaded API from their DLL main.
Of course.
And the delay load tried to load the DLL, which failed because the loader lock was held. And
it wasn't so straightforward, yes.
Yeah.
But, always be careful in what you do in DLL main, and just don't do anything. That's the safest thing.
So there was that. I think the nastiest code I've had to look at is, so on Windows, our line terminator is a carriage return and line feed, not just a line feed like certain other platforms. And the logic required to do this translation and to do it correctly and to make sure that seeking and getting the file pointer work correctly is very complex. And so I've had to debug through a lot of that. We actually we have a long-standing issue where if you have a file that uses just / and line endings, just Unix style files, seeking may end up causing the file stream to end up in a corrupt state, and this was reported on Connect a while back. And so we looked at that, and we really I really wanted to fix it, but after spending a day on it, I was like, there's no way that we could fix it with high high certainty that we're going to completely break it for everything else.
Yes.
So hopefully, as we're improving the code, with newer features and reducing complexity.
And depends when you can fix certain bugs. The time is important. Right? You can't fix it to risk, to destabilize the platform, but early enough, in the product cycle is definitely the right time to do it.
Yeah. This one was reported very late. There's just no way.
It's tough. Well, thanks for reporting the bug anyway, whoever did it.
Whoever it was, it was interesting to look at.
Yeah, it was great.
So,
cool. Well, thanks very much, James. This was super fun.
Cool.
Hope you had fun too. I had.
I hope it was interesting to people.
Yes.
But,
okay.
Yeah.
Great.
Follow me on Twitter.
Okay.
Yeah. I'll put my link on there somewhere.
Absolutely, yes. We'll add more fun. We probably even write down the code. It's not that large.
Yeah.
Okay, thank you. Bye-bye. Have fun.
Bye.
More zero times.
Dude, James is such a nice guy.
Yeah, he's a really nice guy.
Cool.
Yeah. So it was nice also to stay in his office, look at the
school.
the bear, all the stuff that he has in the office. Old school, yeah. So I really like the Stack Overflow part, and the template tricks. Working in a node code base is always interesting, and that's real shit. It's definitely important to write new code, but there's a lot of people out there that are to maintain and move forward code bases. We know one. I was talking with Tom Kirby-Green last week.
Yes.
About some of the things he has to do. So that's I think that's useful.
Awesome.
Send more questions. Let us know what you think about it, as usual.
Well,
and we see you at
Going Native. But I do want to say real quickly, I mean, the idea behind Going Native, and you're learning this here first, is that we're going to do 3 days, not 2.
All right.
Nobody knows what any of the talks are. So if you go to the Channel 9 site, you'll see that it's just a list of names and a description I kind of wrote. And you have no idea what these people are going to talk about. By design,
that's cool.
It's going to be a mystery, but we will post the talks. But on day 3, you have no idea what's going on. It's going to be even cooler.
Yeah.
There's going to be lightning talks. There's going to be people from all over the company that are going to join in. Bjorn might do a 20-minute talk.
Yes.
Scott might do a 20-minute talk. It's going to be really interesting. And what you just said about using templates in this way could be a really good talk. How do you move an old code base further?
I like the 20 minutes format. Yeah,
right on, man. So register.
Register, we'll be there.
We'll be back in when? August?
August.
Boom.